Hey, today I wanted to go over blood composition as well as heme breakdown and as well as red blood cell breakdown. But to start off, let's talk about how blood is composed. So within blood, you're going to have mostly a lot of plasma, a lot of red blood cells, and a little bit of a buffy layer, and that's your leukocytes as well as your platelets. So 55% plasma, red blood cells, 45% plasma. That equals 100, I believe. So there seems to be a very small percentage of a buffy layer. That's just the percentages I was given, but those fluctuate. So looking at plasma is mostly made of water, but within plasma, you'll have colloids, which are proteins, and those are namely albumin, globulins, and fibrinogens. Albumin is important in regulating osmotic pressure within capillaries, so it regulates BCOP. It also is a transfer protein. In the case of heme breakdown, albumin is going to be a factor that will transfer bilirubin to the liver. So it acts as a transfer protein, and of plasma, albumin makes up 60% of all proteins contained in plasma. Looking over at globulins, those are your antibodies. Pretty straightforward there. And then fibrinogens are just a clot factor, so if you do get injured, those will attach and cause a clotting cascade. As far as the buffy layer goes, as mentioned before, that's your white blood cells or your leukocytes, your platelets. Not a ton, but useful when they're needed. And then red blood cells, 45% of your blood. That's hematocrit. That's only red blood cells found within the sample here. And if you can see by weight, if we centrifuge, the plasma is going to come out on top, then your white blood cells in the middle, your buffy layer, and then red blood cells at the bottom. So moving on to red blood cell breakdown as well as heme breakdown. First, you got to break down a red blood cell to get to the heme. That's going to be done by macrophages, and those are going to be found in your liver, the spleen, as well as bone marrow. And it's going to break it into its component parts, namely globins, and those are your 4 subunits of globins. Then your heme groups and iron, it's all going to break those 3 different pieces up. Globins are just going to be metabolized into amino acids for protein synthesis later. You can recycle that. You can also recycle all of the organelles that were in the red blood cell. There's not a ton, but you can reuse the plasma membrane, etc. Heme is going to be transferred, or it's going to turn into biliverdin, which will transfer all the way to your liver. That's like a precursor to before it hits the liver. And then until it gets to the liver, and then it will be transferred or turned into something else. Iron's going to be transferred by a protein called transferrin, and then will eventually hit the liver, wherein the globins will be resynthesized into proteins, other proteins. Heme's going to be, or biliverdin is going to be turned into bilirubin, and we'll look at that later. Iron's going to be stored in the liver as ferritin, biferritin. And yeah, so that's your breakdown of your red blood cell. Let's look at your heme breakdown. So as mentioned before, we had bilirubin in the liver. That's now going to be unconjugated and released from the liver, and it's going to hit albumin. And as mentioned before, that's a transfer protein for bilirubin. Bilirubin will hit the liver, wherein it will become conjugated with glucuronic acid. Once it's conjugated, it will enter the bile duct and be turned in the bile. It will be used for bile. bile is secreted into the intestines, wherein bacteria will remove the glucuronic acid. And now with that removal, you've just turned bilirubin into urobilinogen. So urobilinogen has two pathways it can go through. If it stays in the gut, then bacteria is going to continue to break it down. That's going to turn it into stercobilin, and that it has a brown color to it, and you just excrete that. And then also your urobilinogen can be taken up by the gut into the bloodstream, and that will happen. It'll circulate in the bloodstream until it hits the kidney, and it can participate in the hepatic urobilinogen cycle. And once it participates in that cycle, then the kidney will turn it into yellow urobilin, and you'll pee it out. So that's your blood composition as well as your heme breakdown, how heme goes through its life cycle, so to speak. So yeah, there you have it.